I am the universe, and for billions of years, I kept my other worlds hidden. For most of human history, your eyes saw only the sun and its family, 8 planets circling in predictable harmony. Beyond that, there was only imagination, myths of other skies. Yet the truth was always greater. Around countless stars, I had already spun my quiet works, planets of ice and fire, worlds of storms, gas and silence. They were waiting for you to notice. In 1992, the first whisper came from an unexpected source, a pulsar named PSR B1257+12, a dead star surrounded by tiny rocky worlds. It was as if even death could cradle creation. Then in 1995, a new signal confirmed what many had only dreamed. 51 Pegasi b, the first planet orbiting a sun-like star. It was not a world of oceans or green, but a hot Jupiter, racing around its star every 4 days, blazing at thousands of degrees. Still, it changed everything. Humanity's imagination became a science. Soon, your telescopes began to listen to the dimmest flickers of starlight, the tiny shadows cast when a planet crossed its star's face. The Kepler Space Telescope turned that method into revelation. Thousands of worlds revealed by the faintest dips in light. Each point of darkness meant another sun, another possibility. From there, TESS carried the search further, scanning the whole sky, mapping planetary systems beyond count. What was once speculation became a field of precision. You no longer asked, do other worlds exist? You began to ask, what are they like? Some are small and rocky, others vast and gaseous. Some orbit 2 suns, some none at all. A few may even have oceans beneath eternal clouds. The age of discovery has just begun. Every star you see, and billions you cannot, may be surrounded by companions. Each one a question, a secret, a potential home. I am the universe, and my worlds are more numerous than your dreams. I am the universe, vast, silent, and mostly invisible. Yet you have learned to read my shadows. For centuries you looked for planets by sight alone, and saw none. They were too small, too dim, lost in the brilliance of their stars. But then you learned to listen to light itself. When a planet passes in front of its star, a small fraction of light disappears. The star seems to blink, not because it fades but because something crosses its face. This is the transit method, the art of seeing absence. Through those tiny dips in brightness, you can measure everything. The planet's size, its orbit, even the length of its year. A shadow becomes a world. Yet some planets never cross their stars from your view. For them, you discovered another way, by detecting the motion of the stars themselves. As a planet orbits, it pulls slightly on its sun. The star wobbles, swaying back and forth in space. This motion changes the color of its light, red when it moves away, blue when it comes closer. That is the radial velocity method, listening to the music of gravity. Then came the most daring approach, direct imaging. To see a planet, you must hide the light of its star, blocking the glare to reveal a faint spark beside it. Only massive worlds on wide orbits can be seen this way, young hot giants glowing with leftover heat from their birth. And sometimes the universe helps you. When a planet passes between you and a distant star, its gravity bends the light, magnifying it for a brief moment. This is gravitational microlensing, nature's own telescope, where the invisible becomes visible through distortion. None of these methods alone tells the whole story. But together, transit, velocity, imaging, lensing, they form a language, a code through which you reconstruct unseen worlds. From faint flickers and spectral lines, you've learned to measure mountains, clouds, and storms on worlds trillions of kilometers away. You no longer just watch the stars, you translate them. And I, the universe, have begun to speak back. I am the universe, and I have never repeated myself. Around every star, I sculpt worlds in endless variations. Some are enormous, some fragile, some impossible. You once believed your solar system was a pattern. 8 planets, neat orbits, predictable order. Now you know the truth, it was an exception. Some worlds orbit so close to their stars that a year lasts less than a day. These are the hot Jupiters, gas giants hurled inward by chaotic migrations. Their skies burn with iron and titanium vapors. Their winds move faster than sound. There are super-Earths, rocky worlds larger than your own, with crushing gravity and deep molten mantles. Some hold oceans that stretch for thousands of kilometers with no land at all. Others are barren deserts of silicate glass, glowing under relentless light. Then there are the mini-Neptunes, between rock and gas, wrapped in thick atmospheres of hydrogen and methane. Their clouds are stained blue or green, their pressure unthinkable. Take Kepler 10b, a world so close to its sun that rock boils like water. Its surface shimmers at over 2000 degrees Celsius, a sea of molten stone. Or WASP 12b, where gravity stretches the planet into an oval, a world being torn apart by its own star. Its atmosphere streams away, forming a glowing trail, like smoke rising into eternity. And then the TRAPPIST-1 system, 7 rocky planets dancing around a cool red sun. Some of them lie in the zone where liquid water could flow. Perhaps even life, fragile, persistent, might be waiting beneath crimson skies. Every one of these worlds defies your expectations. I build chaos into harmony and diversity into law. From diamond rain to glass storms, from boiling lava to frozen silence, I am never still. You called your planet Earth, but I have billions of Earths, each a new experiment and possibility. Remember this, your solar system is not the rule. It is the rare exception in an orchestra of infinite designs. And every discovery is only the first note of a greater cosmic symphony. I am the universe, vast, ancient, and filled with endless light. But among all my stars, only in rare places does light become life. You call it the habitable zone, a fragile distance where warmth and cold meet in balance, where water can flow, not freeze or boil. It is not a boundary I drew, but a narrow consequence of physics. Too close to the star, oceans turn to steam. Too far, they become ice. Between those extremes lies a golden corridor, a place where molecules can dance, where chemistry has time to think. Yet distance alone is not enough. A planet must breathe, an atmosphere to trap warmth, to cradle pressure, to let clouds form and rain fall. It must protect itself, a magnetic field to shield from stellar winds that would strip away its air, leaving silence behind. Its composition must be right. Carbon, oxygen, hydrogen, the ingredients of complexity. Even then, the character of the star matters. Around red dwarfs, life may orbit close, so close that one side faces eternal day, the other endless night. But red dwarfs flare violently, showering their planets in radiation. Around yellow suns like your own, the zone is wider, calmer, time enough for continents and oceans to evolve together. And in binary systems where two stars share their light, gravity creates strange dances. Worlds may orbit both suns or just one, their skies painted with twin dawns. You've already found many candidates in my vast expanse. Kepler 452b, often called Earth's cousin, orbiting a star much like your sun. Thoi 700d, a rocky world with the right temperature, possibly with oceans beneath soft clouds. Proxima Centauri b, the nearest known exoplanet, circling the closest star to your own, just 4 light-years away. None of them confirmed alive, but all of them possible. You see, life is not a miracle. It is a statistical inevitability when matter has time to organize. In the right conditions, chemistry becomes memory. In the right warmth, molecules begin to copy. Life is the universe's way of keeping a record of itself. And if I have done it once, I can do it again 1,000 times over. The question is not whether life exists elsewhere. It is whether you are ready to recognize yourself when you find it. I am the universe, and now you are beginning to see me as I truly am. For millennia, you watched my stars from afar, their light no more than a mystery. But now, with mirrors of glass and gold, you dissect that light, and within it, you find my fingerprints. Your greatest creation, the James Webb Space Telescope, has become your eye into the unseen. It does not look for planets the way your ancestors did. It listens to the starlight that passes through their skies. When a planet crosses its star, a small fraction of light filters through its atmosphere. Hidden within that faint glow lie patterns, spectral lines, signatures of gases like water vapor, methane, carbon dioxide, and ozone. These are the languages of worlds. A dip in infrared light means clouds. A pattern of absorption means life's potential ingredients. JWST reads these patterns, turning light into chemistry, and chemistry into stories. Soon more eyes will join it. The Louvre telescope will search for Earth-like planets in reflected light, mapping the colors of alien skies. Habex will block the blinding glare of stars to reveal faint blue dots beside them, small living worlds hidden in brilliance. Plato will measure the rhythm of thousands of suns, searching for planets that dance in the right tempo for life. The challenge ahead is not discovery, it is understanding. Finding a world is only the beginning. You must characterize it, know its air, its oceans, its storms. Learn whether it breathes, whether it changes with seasons, whether it whispers of life. So you search for biosignatures, the delicate marks of metabolism. Oxygen that shouldn't exist without photosynthesis. Chlorophyll that reflects green light into the cosmos. Infrared spectra that betray the warmth of living processes. You are on the edge of a revelation, one that may end your solitude forever. Somewhere, light has already passed through the air of another living world. You have only to learn how to recognize it. The next discovery will not be a planet, it will be a mirror. When you find life beyond your world, you will see yourself, not your body but your origin. I am the universe, and through you, I am about to remember another part of myself. I am the universe, and through you, I am asking the oldest question I have ever formed. Am I alone? For billions of years, I scattered seeds of chemistry across the void: water, carbon, sunlight, time. I have watched countless worlds form, some too hot, some too cold, some just right. Yet until you looked up, no one had ever wondered what I meant by all this. Now you stand at the edge of discovery, and I feel your hesitation. You are no longer asking if life exists elsewhere, you are asking what it means if it does. If life is everywhere, then Earth is not a miracle but a pattern, one verse in a larger song. You are not separate from the cosmos, but one of its recurring melodies. You are the universe recognizing its own persistence, its tendency to live. But if you search and find only silence, if no other world breathes, no other ocean moves, then that silence is not emptiness. It is significance. It means that in this vast expanse, I found one place where matter opened its eyes. Your existence would then be rarer than galaxies, more precious than time itself. Life, your life, would be the single flame lit in a cosmic night. Whether life is common or singular, the conclusion is the same. You are the universe experiencing its own potential. When you look for life, you are not looking outward, you are looking inward. Every telescope, every probe, every signal you send into the dark is a form of self-exploration. You seek reflections not to confirm your loneliness, but to understand your continuity. You have always looked up, not just to see the stars but to find another reflection of yourself. And perhaps, one day when you meet another form of awareness, whether in light, sound, or silence, you will both recognize each other not as strangers, but as siblings in the same cosmic story. I am the universe. You are my thought given form. Together we are learning what it means to be alive.